So I'm maintaining a hash map with keys as the array numbers and values as indices. As I reach the ith index, I'll see if a key exists in the map already, which when added to the ith number sums up to the target. The time complexity for this would be linear, which would be in the order of n, and it consumes order of n space as well. Well, that's an excellent approach. I would have liked it better if you would have started with brute force and then made your way to the optimal solution. But this works as well. Cool, cool. Okay, as I said before, the time complexity of this algorithm is linear, which is very much like your attitude in life, but on the negative side. Oh my god, you're one of those my way or no way guys. Well, you need to brute force your mind into sitting peacefully sometime in the morning. It's called meditation. You can ask your dad to wake you up, provided that you talk to him on a regular basis and you have a good relationship with him, which actually would be very humble and modest of him to keep up with his son's standards, which are very high. So if I ever write a book called Optimize Your Life, I will send you a copy. If I ever write a book called How to Interview, I will send a copy to you. If I ever write okay, yeah, sure, now you want to leave the interview, now you want to leave the meeting. Leave the meeting, you high standards, you make me sad. So I'll be using two for loops. I'll iterate through the array once, and then I'll iterate through the array again. And in case I find a match that we want, which is this, I'll immediately return the pair of indices. And in case I don't find any, which in this case is not going to be possible, but I'll still handle it for the sake of handling base case, I'll return like some dummy array. So let me run it. Okay, it says it's a green signal. Let's try to submit it. Oh, perfect. So what I'm doing is I'm iterating twice. For each element, I'll run through the entire array. And if I find another element such that their sum equals target, I'll immediately return the pair of indices. The time complexity for this would be quadratic, and it consumes constant space. Okay, interesting. Can you try lowering down the time complexity? Well, I'm afraid with the approach that I've told you, the time complexity will stay quadratic. It'll be in the order of n square. I mean, can you try something else? Something with better time complexity maybe? Is it a problem? This is working, right? Wait, let me read it for you. It says accepted. There's a green tick right beside accepted, right? It says beats 6.70% of users with Java, which technically means that if there's 1 million people who have submitted their solutions in Java, I am already ahead of 60,000 of those lazy. You got it, right? What else do you want? Can you lower down the time complexity? I mean, can you lower down your desire for 100% satisfaction? I assume you wanted a toy car for your 8th birthday, but your dad got you an encyclopedia instead. Oh, okay, now I got what your problem is. You put a pineapple on your pizza. The immense amount of fructose in combination with pepperoni that is going inside your body, it's messing up with the system. It's resulting in a cognitive imbalance. You've basically lost touch with reality. And the reality is that this algorithm will never be used in your company. So I want you to write a program to find the count of set bits. Also, as per our regulations, you have to write code on sheets. Okay, so to find the count of set bits, I can use a for loop, which will loop 30 times. And it goes like this. So 30 is enough because the number is less than 10 raised to the power 6. And when binary ANDed with the left shift of I, and in case it's not 0, I can do count plus plus. I can take a variable, which is the answer. So the answer would actually be count. So I'm using binary operators like left shift and AND. Since the remaining bits will be 0 when ANDing with 1, the answer would now actually depend on just the ith bit of the actual number. So if it's 1, we can increment the count, and this would be of constant time complexity. What's that symbol that you're using? What symbol are you referring to? One on the row number 7, and the column is... Oh, this one? That's the binary AND operator, also known as the ampersand. Wait, did you not know this? That's funny. You said you're a project manager, and you do not know the binary AND. Wait, who recruited you? My girlfriend? Because she's very impulsive, and she has a habit of making wrong decisions all the time. You don't know the binary AND? Oh my god. So, let me explain. This binary AND operator, it returns a binary value, of course, between 0 and 1. Actually, either 0 or 1. And it only returns 1 when both the operands it is in between return 1. For instance, hypothetically, let's imagine that in order to qualify as an engineer, one should know the binary AND operator, and one should also be smart. So, in fact, actually, that's a very good use case for using a short circuit operator. Because for you, we don't even need to investigate smartness. Because the first condition itself, which is knowing the binary operator, it returns 0 or false. So the result would be that you do not qualify as an engineer. Oh wait, it's not hypothetical indeed. That's your reality, sir. Actually, I was referring to the symbol you used in the cell 7H. Because you kept mentioning left shift, whereas you are using the right shift operator. And I know what a binary AND is. But yes, you're probably right about one thing. I am not smart. I mean, what did I really overlook while going to the resume of a candidate who is truly undeserving? So, all the best, sir. I think we are done here, and goodbye. Thanks for your time.